So this is the agenda we have today. So I'm doing our little welcome introductions. First, we're going to hear, after I speak, from Dr. Nguyen on how she uses Beyond Labz with her classes in organic chemistry specifically. And then after her, we're going to hear from Dr. Pate. He's going to share how he uses the labs in general chemistry. After we hear from our guest speakers, we'll hear from Brian Woodfield. He's one of our co-founders at Beyond Labz. He's going to give us a sneak peek of the new HTML5 based version of the labs. And then we'll have some questions at the end. We'll gather together some of the biggest questions from the chat and the Q&A and answer them, have them answered by Brian or myself. We do also have up a little poll. We would ask you, if you have the time, go ahead and take that. You can do it anytime during the session today. Okay, we'll go ahead and turn the time over to Dr. Nguyen.
All right, thanks, Kelsey. So I'm just going to share my screen quick here. So I started using Beyond Labz in my class last summer when everybody was online, and I thought it was a really fantastic program. So even though we are back to face-to-face instruction in the fall, we still use Beyond Labz as a filler in between. So we split up our labs so that half of the students are in there to have the social distancing. So they're doing wet labs every other week, and then we fill in the off weeks with Beyond Labz. The way that we introduce this is I have a write-up, so they're used to seeing this format of the objective and then the instructions. And initially, it's just for them to walk through the lab and get acquainted with it. So they come to this screen, and then they can enter the organic lab and see the different reagents here. So I kind of have a treasure hunt for them initially this assignment where they can just hover around in the actual lab and see what things are. So they're asked to label these. So this is the first lab that they do. I even had them do a couple of reactions so they can get accustomed to moving things around with the flasks and adding the Jones reagent and see what color it turns. At this point, they don't understand the chemistry. They just see that there's some chemical reaction happening, which is great. So after we've done some chemistry in the class, I'll switch the kind of the format of the instructions to where there's an actual procedure. So they get what reaction that they're doing. And then I believe these labs I've posted in the community. So if anybody wants access to them, there's the Word documents there. But this is, I've kind of taken what Kelsey posted and gave us as instructors and made it into suit our students. But it also has the notebook sections here, how the students set up their notebooks, what is useful for them. So they're seeing the reaction and they're given really detailed instructions. In a regular organic setting, we have them write these detailed instructions. So I have things like the grams that they're pretending to use that they don't actually weigh out, but then they're asked to calculate yields later on in their lab procedure. So I have cues for them where they need to do things in their notebooks or with questions or where they need to add things to there. But mostly they enter in the organic lab through the synthesis window. I don't have them use the worksheets just because some of the experiments that I've set up for them aren't the ones that are listed here, but there is a lot of room for them to explore. So if we're working on halogenation, I'll just have them click on that and they can see all the different reagents. What's great is if they're not sure what's in the flask, they can just click on that. But we have them either double click or drag a reagent over, and they can go to hover over top and see what reagent is currently in the flask. And then they can sometimes are directed exactly what to do. So maybe the first 3 or 4 experiments, we tell them exactly what reagents to add to the flask. And then later they're asked to get a target molecule once they've done some synthesis projects or synthesis in their lecture. They know what reagents could be used to get there. So I might just have them open up the alkene bromination and give them the product, and they have to figure out what starting materials and what reagents. So here I have ethanol and tert-butanol, and they can also explore also if they're going to have multiple products that could happen in this one. So if I decided to add this, and one of the great things about Beyond Labz is they're not tied to reagents. They can do whatever they want. So I'm going to add this PCC and start up the reaction by clicking on the stir plate here, and you can advance the time. So some students, I don't think, figure that out right away. But now I have a holy mess, an unholy mess of reagents, which would happen in normal setting. So as you progress the time here, you can see the reagents are changing. and it tells you what is in the flask. One of the other things that they can see here is that after a while, it's not changing. Um, so they have the ability to see what is in here, and they can do any analysis. They have to do workups. So we have them drag the separatory funnel over. And so one of the things that I have on the worksheets is if you have a base in solution. So if there's pyridine here, this is basic, you need to do an acid workup. So the white bottles up front are what they use for an acid workup. They can just drag it over to the top here, and you can see it also automatically adds an ether layer. And then they should know that, or you tell them that the top layer is usually organic based on the densities. And then they had this over here. And then we have all these different tools for doing analysis. They can do TLC plates. You can set that up at the beginning. I forgot to do it at the beginning of the reaction, but I do direct students to do the TLC plates at the beginning. They can monitor the progress of the reaction. So we'll have them take a TLC plate of just the starting materials, halfway through after 10 minutes or so, and then later at the end, so they can see how the polarities have changed. So some of those reactions can be monitored by TLC. We can do an FTIR spectrum and save that to the notebook. So if you save this here, they can point out that there's an OH functional group. Click OK. You can do mass spec and get your mass ions there. You can also save that to the notebook. And also there's proton NMR and also carbon NMR. And these areas can be zoomed in on. I can zoom out. And so they can do the different integrations. Some students need help with the integrations because the numbers are not always perfect in the bottom, but we do teach them how to figure that out. One of the things that the students complain about is if they did the reaction today and they came back to it tomorrow, their integrations have changed, but the math is still the same. So we try to explain that as well. So all of these things can be saved to their lab notebooks, which can be found here. And they just have the spectra here. And this can be stretched out. These are things that I didn't know right away, but have found later on to be helpful. So the size of these windows can change so that you can either have students turn in the lab book. We talked about the panelists earlier that they have problems saving these, or they can do a nice screenshot and get all of this information in here as well. So there's the NMR that the students took. So the reactions are great. And then if they make a mistake, they can just clear the lab. Sometimes I have students add reagents if they're trying to do an aldol. And they want to heat up the reaction, and they remember to put the condenser on here, but they start it up and forget to put the nitrogen outlet on here. It does blow up. Which is, I think they find it enjoyable. Maybe they do that for fun anyways. Sometimes if you cook reactions too long, it does turn into tar. So when my kids were home with me last summer, would always request me to make different methods of tar. So it does kind of mimic some of the same reactions that you're doing. If you did cook it too long in the lab, you can see that there are consequences to that. Again, if they blow something up, they can just come back and restart it. But there's a lot of flexibility with the reactions. And again, I mentioned that I do a lot of these where it wasn't one that was intended to write, but the chemistry is so great on here that we can just do a lot of things. Or when I've written lab manuals for our institution that took me, a whole entire summer because I had to do reactions by hand. But here I can do 60 reactions in a day in a short time period. So it's been really great to have these labs here. And the students that last semester didn't get much time in the lab were able to come in this semester, and they knew things about working reactions up. And so I don't think they lose a ton of experience having to use the virtual lab versus being in person. So that's my experience. And again, the workshops that or the worksheets are shared on the community for Beyond Labz as well.
Awesome, thank you. I loved your introductory activity. That's pretty cool. Get them used to the software and looking at the synthesis lab. Did you have anything else you wanted to share?
I think the intro activity just helps them there's a little bit less pressure because they're exploring it and doing some kind of fun reactions and seeing it before they have to actually do a lab. So I
Yeah.
feel like that helps them a lot with that. But yeah, I think that's what I had. And other people have questions, we can get to those.
Yeah, we'll probably save those till the end. Thank you so
Yep.
much for sharing.
Thank you.
Okay, if you want to go ahead and you can stop your screen sharing. Now we'll hear from Dr. Pate, who's going to talk a little bit about using Beyond Labs with general chemistry.
Yeah, thank you. I would echo some of the things you just heard too, that what I thought was pretty impressive about the software was the flexibility of it. Because I'm also teaching organic and I've used this for organic. And so the fact that, you might be looking to do an epoxidation reaction or whatever, whatever option you're looking for. And it's what's given to you as options. You might have 3 or 4 alkenes, but in fact, you can try any of the alkenes that are available elsewhere and they all work. It's pretty impressive. And so I would often do the same kind of things where I'd have my students using things that were going beyond what was actually suggested in the software. Let me go ahead and share mine. So that's not what you need to see. That's not either. I had it up here, but I got too many Word documents open. So here it is. So I'll give you a little bit of background. So my situation is like everybody else's. I mean, I got thrust into virtual stuff because of COVID last spring. And so we were trying out different things in our effort to try to survive that spring semester. What are we going to do for the next 6-8 weeks when we don't have labs to go to? And so we tried Chem Collective out, and that was fine, which is a free one online. And then we kind of worked ourselves, stumbled around and stumbled onto this. And so I played around with this. And I think, if I remember right, I think this was being offered for free last spring to help organizations out. I'm pretty sure that's how we got involved with this. And I was so impressed with it that I picked up and developed an entire summer online lab. And the reason I did that is because I had no confidence that we were going to be coming back this fall. I had no idea, meaning fall of 2020. I had no idea whether we were going to be back in session. And I felt like we needed to have something ready to go. And so I had also promised students back in the fall of 19 that we would offer general chemistry in the summer of 2020. And so I didn't want to, go against my word there, even though the situation had changed. So I developed this where it was literally a 2-semester course using almost exclusively Beyond Labz experimentation. So this, you can actually see, we're going to actually continue teaching this as what we call principles of chemistry. It's going to be what we're calling a terminal lab experience. So for like our petroleum engineering majors and others that do not need to go on to any further chemistry, they're actually going to be allowed to count this as their chemistry lab courses for a small number, and they're going to choose to do this in the summertime. Otherwise, most of them are going to still take the traditional traditional lab course. But we also are doing the same thing where, because of social distancing, at least in the fall and then in this spring semester, we also split our labs. So half are coming one week, half coming the other week. And so similar to what you heard before, half our students will do a live experiment one week, while the other half will do the virtual, and then they switch places the following week. And so anyways, I just thought you might like to see like the experiments that I've done. I have 12 experiments for Chem 1 and 12 experiments for Chem 2. Now there are a couple here that are not Beyond Labz. I highlighted these. These are ones where I got my GoPro camera out and I actually was the hands in the lab, and I just, without saying a word, I just acted like I was a student and I did everything. And then they had to observe it and do all the stuff. But everything else you see here are the Beyond Labz type of experiments. Okay, so all these, and I think there are 9 or 10 in each of the sessions. And so I thought I would just highlight a couple of things I did with these. So if you look at any of these, like for instance, like the development of the atomic model, that is my experiment in a sense, but it utilizes 3 different experiments from Beyond Labz. So it utilizes the Millikan and the Rutherford and the Thomson experiments, which are all really cool because for the first time in my 20 years of teaching, I didn't have to just stand up front and try to describe these experiments to students. It was really cool that they could kind of simulate these things, especially the Millikan one. I love the Millikan one, the oil drop experiment, because you do some really cool measurements on that. Calculations are fantastic. I was really impressed by that one. They all are great, but that one especially I thought was awesome. And so that development of the atomic model experiment was really a combination of 3 things from Beyond Labz. A lot of the labs, the can, so to speak, the prepared labs from Beyond Labz, they're relatively short. They're designed to be relatively short. So they're things that, you might finish in 10, 15 minutes, 20 minutes or something like that. They're relatively short, but if you combine a few of these, because I didn't want the students to get out of this in 20 minutes of lab time. I wanted them to actually spend some time on it. So I would combine these into multiple things. The electronic transitions ones, the one that you see there, that actually involved, again, like a couple different ones that Beyond Labz had prepared, where they're looking at atomic emission spectra. And again, what was cool about that was they're actually seeing and then in real time doing the kind of electronic transition calculations that we would expect them to see. And so I thought that was really effective as well. The nomenclature solubility one, it's funny how your brain works, because I was thinking, man, I was really proud of this one. I really took what Beyond Labz had done, and I really made something cool out of this. And I looked back at it this morning, I was like, oh, actually, I guess I just did what they had. So it was actually exactly what they had done. I had added like 2 other things onto it, but I was like, man, that's one I was really proud of. And apparently I just actually had done what they had said. But it is cool because what they're doing in that experiment, and I'm going to show you a couple things in a second, but what they did in that experiment is you basically just drag test tubes and you put different ions together and you see, what forms a precipitate and what doesn't. And if it does form a precipitate, it shows you the chemical formula, it shows you kind of what it looks like. In cartoonish fashion, it's white or it's brown or whatever. And then they have to take the step of doing the inorganic nomenclature of it. So it wasn't just a boring name this thing. They were active. They got to put calcium and carbonate together and see, oh, wow, calcium carbonate formed a white solid. Okay, and so they actually had to get to see something along the way. Qualitative analysis, I did in 2 different experiments here in the I'm calling the fall semester, but the first semester. These experiments were called Identifying Unknown Metals and Identifying Unknown Metals 2. And what I did in those is the first one was very much the canned experiment that Beyond Labz had provided. And then on the second one, I required the students to kind of figure it out, to do a little bit of trial and error to figure out how to separate their ions. I thought I would actually show you what I did for that one, for the first one at least. I had a how-to video that I created. Oh, darn it. Too many things open. Bear with me just a second. Actually, I guess the how-to video is for a different experiment, but I thought I'd just quickly show you. I put these together. The audio wasn't great on these at the time because I didn't have a good headphone, but I basically put these together to show them how to do things.
Than the one we used previously. So what you're going to be doing here, the primary things you'll be doing is first thing is just to grab a test tube out of this box, you click on it and drag. You know, you can click it, you just move it over to the clamp and it'll lock into place, let go of it. Right now it's obviously empty. You will then come up here into the stock room and you'll grab whatever ion it is that you're supposed to grab. So in the first one, it says you grab the silver ion, Ag+. So if I click on that, you will see it now fills up the test tube with Ag+ ion. It tells you what's in it, it tells you what it looks like. And you'll have to be using both of those as you do the experiment. You'll be looking in here to see what you see. You will also be looking down here to see the formula or whatever it might be. It does tell you to divide this. And so if I get down here to this test tube, notice how it says divide. If I click on this 4 times, watch him here in this blue test tube rack. Watch what happens. 1, 2, 3, and 4. You can see that I made 4 duplicate solutions. Each one of those I drag over there, these are all Ag+ ions. So you now have 5 test tubes containing the Ag+ ion. It then tells you to go through one by one. You're going to be adding these 5 reagents over here. I don't know what order, but you add the Na2S, NaCl, Na2SO4, NaOH, and Na2CO3. So let me just do a couple of these as examples. If I were to do the Na2S, I'll start right here. I'm just going to click on it, and that's going to add the Na2S to the test tube. You don't have to like drag it. You simply click on it. You see my droppers over top of that. I'm going to click and watch what happens to the test tube up the upper left. As I added the Na2S, notice what happened, that I now created some nasty looking brownish, blackish solid.
Okay, I don't want to take too much time doing that, but you get the idea. Like, I was able to put together these things so the students could actually see what to expect along the way. And you can see how you might utilize that in terms of like the nomenclature and solubility one. And then when you really get into the qualitative analysis, that's where it gets even more interesting, because that's where they are separating the different metals, getting different precipitates, doing not only the the formation of those, but the centrifuging of those, the separation of those. It really mimics what you would be doing in a lab very, very well. So I really like that. And like I said, I was able to walk them through in that first experiment. And then when we got back to the second experiment, really put it more in their hands. The one when I got, to stoichiometry, so these things more or less, go along with what we're doing in the lecture course. And when I got to stoichiometry, I don't want to say disappointed because that gives the wrong message, but there was really nothing. I was looking through all the options from Beyond Labz. I was like, boy, there really just isn't something about stoichiometry here. And so I was really struggling with what I could do. But then what I realized was there's a really great experiment that works perfectly for stoichiometry. And it was called the, well, there's actually two different ones. Let me drag it over here and I can show you what I used. Whoops. So for the stoichiometry experiment, this is the write-up that I had created. We did two different experiments. The first one was the analysis of an unknown KMNO4 solution. So this is actually in the electrochemistry part of the Beyond Labz collection. And what I realized is that this is actually a very complicated balanced equation. So when you go and balance this thing, you got 5s and 4s and 9s and 2s and 8. I mean, it's all over the place in terms of when you balance this thing. It's an awesome equation to balance and to do stoichiometric stuff with. And so even though titrations was down the road, titrations is going to come up into the second semester, the experimental steps you were doing here were easy enough that a student could do them without having any great understanding of titration at all, and really led to a great way to do stoichiometry. Because like I said, because you didn't have 1-to-1 or 2-to-1, you had these awesome 5-to-4 or 4-to-9 kind of relationships. And so I had them do that. And I will just open that one up real quickly to show you what that one looked like. Under electrochemistry, here's the standardization of potassium permanganate. And you'll see how realistic this is. If you've never seen this before, it really is quite realistic. You open up a drawer full of beakers, you drag a beaker up here. If you want to weigh something out on it, you zoom in on the balance, drag my beaker over onto that. I can either write down the mass or I can just tear it here, open up my bottle, put in some of my chemical, just drag it over here and put it on there, and I got to weight. So I got 0.10 grams of I guess that's the AS203. So here's my beaker right here. I can drag it over, fill it with water, which is kind of fun. Put it over here onto the stir plate and immediately start stirring on its own. You can see the burette here where I'm going to do the titration here in a second. You can also use, and we did in this experiment, we used the pH probe. So we're actually monitoring it, the pH of this. And then you just open the sucker up and let it go. And you can see, you kind of get the close-up view of the burette over here, but you can also see it here in the center. You can actually see it going down. So it's very realistic. I practiced this one this morning, so I know that it takes about 30 milliliters to get to the endpoint. So if you can bear with that. We'll get down there to the endpoint, and I'll show you what you can do once you get close. And what I would have my students do is just run it down real fast and wait until they saw a color change, and then note it was about 38 or something like that. And then I'd have them repeat it. And when they got close to that endpoint, like I'm about to do, they would slow it down to a crawl so I can get an accurate accurate titration. So I know it's going to go right about 30. So you can see that there's 3 different places I can have this, 3 different speeds: blasting, somewhat fast, pretty fast drop, and then that real slow one here, which I'm sure I'm about at the end point. I'm getting impatient because I don't want to take up too much time, but I know it's got to be here. Any one of these drop, there it is, right? And so you can get a very accurate, which is also nice because it allows students to get very accurate titrations in the fall or first semester. And then when they get to the second semester, they're actually doing titrations. At least that's the way our calendar works. At least they've seen it before. And now they can work with their own fingers and try to get good at doing, careful titrations. But I like this experiment a lot. And like I said, part of it is because you can, do some pretty interesting stoichiometric kind of stuff up here. I know that I am way over my time already. I think I've probably gone almost 15 minutes already. I had a whole list of things I could show you, but I think in the interest of time, Kelsey, do you think I should probably let you have the floor again?
Yeah, that would be great. Thank you so much for sharing that. We appreciate both of you guys, Dr. Nguyen and Dr. Pate. We'll move on with our webinar agenda at the end. We have questions. We'll allow you to ask questions to both us at the Beyond Labz team and then to our 2 guest speakers as well. They're willing to answer some questions if you have specific questions about their content they've developed or how they've used it. But we'll get to that at the end. So we're going to hear from Dr. Brian Woodfield next, who's going to give us a a sneak preview of the version 3.0 Beyond Labs that we'll be releasing this August. It'll be fully web-based. So we'll go ahead and turn the time over to him.
Yeah, I want to thank those demos. It's a really a unique experience to see someone else demo something that I've been demoing for like 20 years of my life. And so, but what's particularly interesting was to see a real organic chemist demo organic chemistry, because I'm not an organic chemist. The only reaction I know is esterification, and it's not very colorful. So,
It's true.
so thanks for that. I thought it was really good to see how you're using it. So I'm Brian Woodfield. I'm a professor at Brigham Young University. I've been there for 24 years. I created these labs, and they've been a lot of different formulations over the years. So I want to spend about 10 minutes just kind of giving you a sneak peek of where we're going to go for fall in terms of converting into HTML5. So hopefully you don't, hopefully if you're using these labs, they really, the way they work isn't going to change. The way the labs themselves work is going to be unchanged. So all of your procedures and things will mostly stay intact. We have made some additions that I think we're all really excited about. So I'm not going to be able to kind of demo all the labs, but if you're familiar with them, they'll be the same with new cool things. So hopefully you can see my screen here. So this is the inorganic lab. We are in parallel. Inorganic's pretty much done. Gases is pretty much done. We're still working on calorimetry, quantum mechanics, and titrations. I got parts of those that I can show. Organic chemistry, we're going to start in about 3 weeks. And so we'll have all of the general and organic chemistry ready to go by August 1st. So here's the inorganic lab. And I hope you can see it's the same graphics. We're using the same assets, but so grab a test tube. It works the same. I can click on my cations. You know, I can come here and say, okay, this is my test tube, and I'm going to go get another one. And maybe I'm just going to go add the cobalt and take that one down, and so on. And so works the same, just kind of making different test tubes and of like, hey, I'm going to go explore the chemistry of these individually. But the cool thing here is that the one I introduced is this idea of save the lab, or what we call save state, is that I can click right here and now I've saved this configuration. I can go into presets, I can go to my saved labs, and I can clear the lab, and I can click here and I can restore this. So a student or you can now create your own sets of labs, save them, and it's not working yet because we don't have the server set up to where these are going to be saved, but you'll be able to copy this link right here and then save this link and share it with students. And now they have a preset. All they have to do is click, share the link, and it will open it. So for example, here is a preset that I had saved, and it has all 3 cations in it. And I can go to live data, and now that's where they can see the picture. They can come here and label it. Nice thing is they can save their image to their lab book. And so like before we had a lab book, but now our lab book is integrated in here. Some of the changes we've made to our lab book is that it's now students cannot modify it. So we're trying to reduce the ability to cheat. So it actually provides timestamps. So it's indelible. It's timestamps when they open, when they close the lab, tells them when they save these images. So it's a way of comparing, and you'll be able to view this lab book from when you log in as an instructor. You'll be able to view each of your students' lab books and look at their results. So you can also come over here and take notes. And it's like Slack, once it's in there, but unlike Slack, you can't modify it now, it's permanent. So it's kind of like what we dream of a real lab book. It's ink, you can't change it. You can do superscripts, subscripts, change the size of things, but You will be able to do an export to a PDF, but you'll also be able to view this. So save that image, and so you can really take good notes. So presets, that's our new one. You can also do practice unknowns here. So I'm spending some more time on this, but I can go to unknowns, go to practice unknown, create one. So I can say cobalt, chromium, copper, go to minimum of one, maximum of one, click create. Now I have an unknown. So if I go back to live data, it says unknown, but this is purely for practice. So they can reveal their answer anytime they want. So this is not for any assessment. This is just so they can go through and do their chemistry, you know, go NaOH, go add their ammonia, whatever it may be, look at their lab data, save that image to their lab book. But the cool thing is that we're also going to create the ability for assignments. So here's an assigned unknown that I've created. We're going to make it easy for the instructor to do this, but here's an assigned unknown. And so in here, it just creates a preset, but this unknown, they don't know what's in it. So if I go to live data, it says unknown, they can do all their chemistry, they can make a copy of it, they can go do their flame test here, and centrifuge if they want. So they can do all of this work, but now they have an unknown. And the nice thing here is they go to assigned unknowns. Red dot means they have an assignment. I'm going to click that I have copper, and then what they do is they submit this, and now they see their results, but now those results are now in their lab book. And so you or the TAs can go through and grade them, but now they can't modify this. There's no way to cheat, and it has a timestamp. So there's no way for the student to get in and modify any of this work. So that's pretty much a view of the features that we have that we're adding, but it's all here in this in the HTML5 format. So like I said, we're doing other labs. So here's calorimetry. So here's where we've introduced some changes from the other one, just to make it more efficient on a browser. Is we've kind of turned off this stock room, and we've moved our stock room over here so it's easier. So for example, here I can go pick my coffee cup, and I can come over here to samples, and here's my metals. I can pick a metal, close this. Here's my salts. So maybe I want to go measure sodium hydroxide. So I can drag my coffee cup down here and come over here and add some water to my graduated cylinder, so I know how much I have. Take this, add it. Now I can go to live data. I can turn on my graph, come over here to sodium hydroxide. So I'm going to go measure the heat of solution. I can come over here and save data. So I'll come over here, take my weight paper. So the weight paper is still randomized, tear it, open my lid. Another thing that we've changed, we heard complaints. I mean, it wasn't always the easiest to get scoops. We had problems, and so we've kind of changed how we do it. So here you can click on one of these and get a scoop. So here's a gram. And but we can also do it this way if you want to kind of teach maybe the procedure, how they would do it. They scoop inside, but now you hold it there and it kind of fills up the scoop, kind of keeps on going until they get the scoop size that they want. And so I'll take that and add it. And so now I have my sodium hydroxide. I've been saving my data. Here's my graph. Now I can go drop it and do my calorimetry experiment. So again, all the functionality you're used to in here is still there. It's just over here on the tray that we can go do things. So here's the experiment, and I don't want to wait till it's all done, but units, and come over here and graph it. So I can come over here, save my graph to my lab book. I can come over here, and of course I want to go longer, but I'm just going to stop saving in the interest of time. Come over here to my lab book, and there's that graph that I saved. And here's now that table of data that I've saved, and they can click over here and copy that data now to the buffer so they can analyze it. And again, take notes over here. So this is calorimetry, just show you gases. Again, we've kind of moved things over here to the stock room. So here's the balloon, pick a gas, pick a real gas. So we'll take nitrogen and add it and blow this up. And then again, I can come over here, save data, and I can change my units here and, increase my pressure and increase, round my temperature, and I can increase this, save all this data, and then I can click stop and come back here to my lab book, and here's that table of data. Return the tank, we can do reset, we can do gas mixtures here, of course. We have this piston experiment, ideal gases, turn on a piston, increase the external pressure, or come over here and put in 500 kilograms. So let's go get that in. 500 kilograms and put that weight on and maybe move that to 600 and see what happens. So all of this you can do in gas experiments. So I want to show quantum because we are working on that. So again, we moved the stockroom, which I was disappointed that we had to do that because I thought the quantum stockroom was the most awesome thing because I'm a P chemist. But here's you can still build these experiments. So for example, if we wanted to do Rutherford, I'd pick a metal, I'd come over here and pick gold, I'd pick my alpha particles, I'd zoom down here and I want to detect with my phosphor screen. And then what I do is come here to live data and I'd put on my phosphor screen here and I could turn it on and put my gold out here. Here's my alpha particles, turn it on, and then you get the Rutherford experiment. So move it over here, can move it here. You can go into persist mode and save where these hit. And so all of these experiments are possible. And so of course we've also got titrations and working on that one. And but we are very confident we're going to get all these ready to go, and you're going to have all the same functionality except more with unknowns, lab books, presets, being able to save those presets. You can create your own presets. So for example, in organic that we're going to start, what we're planning on doing is that you'll be able to create your own qualitative analysis unknowns and then have more control over what unknowns are available to the student, like get rid of the easy ones or get rid of the hard ones.
Brian, one question that's come up from a couple of people that have worked with the old labs is if you could just show how you can resize the lab now. Really simple thing, but they were very frustrated with sizing.
Yeah, so you can resize now. Thanks for doing that. So yeah, we can go to about 150% of the original size. So yeah, it's totally responsive now to reflect that. All right, thanks. Yeah, I forgot about that part. That's another new feature. So anyway, that's kind of your sneak peek, and we're on track to be able to do that. We're creating a new portal, give access to assignments, and part of that sneak peek is our content's going to be available in a digital format, and just a lot more integrated experience for everybody. All right, I'm done.
Awesome. Thanks, Dr. Woodfield. I stopped calling him Dr. Woodfield because he was my professor. Everyone on the team calls him Brian, but he was my chemistry professor for several years. So I call him Dr. Woodfield.
I was just going to unmute quickly. Somebody had asked a great question for the panelists, and they had said, how did you organize your course assessments? So how did you choose what activities to use?
I'll jump in here. I just really tried to tie it as much as possible to the course lecture content. So in organic chemistry 1, at least the first couple of weeks is a lot of alkanes. So we did some dry labs, but Once we got into substitution reactions, that was really easy to experiment with a whole bunch of them. And for assessment wise, I had them fill out report sheets. And so there was a little table they had to fill out with, I think I had showed the different masses. So they had to calculate percent yield or theoretical yields. If an experiment didn't work out correctly, so if they didn't get the expected product, they had to figure out what the expected product was. So I just used questions like that, like I would a normal lab report, and then reported those. So students got scores on them as well. So they turned in lab reports that were graded like I would a normal lab.
And I would echo that. That was basically exactly the same thing we did. We developed lab reports that were, report sheets that were exactly analogous to what they would do if they were in the real lab. And so we try to make it as seamless as possible. And we were also trying to tie them as closely as possible to the lecture. I'll say that as an organic chemist, because I did use this for organic as well, the two features I really loved this past fall, because we were doing the same thing of half on, half off, were the C13 and the TLC, because I was able to, again, introduce that virtually. And then when we got to TLC and NMR in the lab, they were just that much further ahead. So that was a really nice feature.
I add something to that, which is, I think, interesting is, we did some research back in the 2000s when we first kind of had the labs come out. And one of the things that we tested and verified quantitatively was for both organic and the inorganic labs was what happens when a student does the lab virtually before they go in and then they do it for real. And two really important outcomes that were verified with like 800 students was if you do the lab virtually before you go in and do it for real, students do about 30% better in terms of how you grade them. And they do the lab up to 50% faster because they already know what they're doing. And so because of COVID and because I needed to, BYU was having a lot of COVID cases. For the first time, I kind of made all my students in my current lab class, purchase a lab and have that access to it. So I made all of my students do the inorganic qual that we're doing. That this is for majors, and I forced them to do these unknowns, and I'm getting 30% increase on their performance on their real lab unknowns, just having them do it ahead of time. So it really does make a difference in their cognitive processing, that they're asking different questions and their brain is processing it instead of like a regurgitative mode. It's now more of a principle-based mode of processing what they're doing.
Other questions?
There was a good question that we're answering now of just how is this going to work this fall with the HTML and the old version of the labs? So for people who've been using the old version, how is this going to work for them? Could somebody chime in on that?
So we are not going to, we do not have the time to convert all of our labs, meaning all of chemistry, physics, and biology products over. So in the fall, all of chemistry, so general chemistry and organic chemistry, will be available exclusively in an HTML5 format. And so the portal, which you're used to accessing the labs now, will be modified so that if you're in chemistry, you'll access the labs just by clicking on the link to a particular lab bench, or you'll click on a specific link or a preset from the portal, and that will launch the lab, however, in the different ways. And so once that lab launches, it should be almost identical to what you're experiencing now. It'll just be on the computer. The other labs, physics and biology, they will work the same way as they do now. There will be a locally installed product. I think you'll find that it's going to be really cool with these preset links, because it's a simple entry point into the lab that you can send out a link. They click the link and it brings them right in. We'll have to authenticate that they're allowed to be in there, but once they're in, the lab will launch and they'll have the lab set up however you want it. And so you can customize your lab activities and just insert a link to the lab you want them to start, click, they're in, they follow your procedures, and they're ready to go.
Okay, so it looks like we have a live question. So let me go ahead and unmute. All right, go ahead.
Hello, could you talk about cost, and also can this be integrated with Moodle?
So, see, the current cost right now is $25 per student for 1 year access. For fall, the cost will go up modestly to, we're planning on going up to $29.95, but that's going to include, unlike now, which is not included, that will include all of our content in a digital format that can be integrated into your Moodle through an LTI integration. So all of that digital content can be tied in and launched, so everything can launch within Moodle through that LTI integration. And the licenses will also be able to be integrated through that, so the students will have single sign-on and be able to access the lab.
Thanks for the questions, Jacob. We appreciate those, and from everybody else. We're going to go ahead and close up now. I'm going to let Dr. Nguyen get back to her busy schedule and everybody else. If you have any further questions, as I mentioned, we'll be sending out that survey that gives you access to the beta version of HTML5. You're welcome to respond there for questions, or send an email directly to Doug@beyondlabs.com. He posted his email in the chat. We thank you again for attending, and we'll also send out an email soon with the recording of this webinar. So thank you for joining us.
All right, thank you, everybody.
Thank you for having me. Thank you.